In this question, we have a given array of prices, and the task is to determine the maximum profit achievable by making a single transaction. If no profitable transaction is possible, we will return 0. So, to solve this, we can initialize a variable called maximum profit to 0. As we examine the prices, if we find a better profit, we update the value of maximum profit, and at the end, we will return that. I will explain this process visually by drawing to simplify understanding. To start, we can only buy a stock on the first day and sell it on the second day. Therefore, we set the initial value of our purchase to the stock price on the first day. From there, we iterate through the remaining days starting from the second day. So let's initialize them. This is our first buy value, sell value, our maximum is currently 0, and let's calculate the current one. At each iteration, we calculate the current profit by subtracting the purchase value from the selling value. If the profit is less than 0, it means we can't achieve any profit and the current selling value is lower than our purchase value, which means we found a cheaper one. In this case, if we found a cheaper stock, so we update our purchase value with the lower price. So let's look at this example. Our current profit is -6, it's less than 0, so it means we found a cheaper stock. So we update our buy value and we go to the next day. Our new sell value is 5, current profit is 4, it's greater than 0, so actually made a profit. So we compare our maximum value with 4, it's greater than 0, so we update our maximum profit. So we go to the next day. Our new sell value is 3, buy value is still 1, new current profit is 2, it's greater than 0. We compare it with maximum, it's not greater than our maximum value, so our maximum value stay as it is. So at the end of this process, we will return our maximum profit and the result is going to be 4. In summary, we iterate through this array, comparing the current selling value with the purchase value. If the profit is negative, we update the purchase value with a cheaper stock. If the profit is positive, we compare it with the maximum profit and update it if it's necessary. This process continues until we reach at the end of the array. Now let's examine how we can implement the solution in code. Firstly, we create a variable called max and initialize it to 0. Additionally, we need a variable to store our purchase value, which in this case is the price on the first day. And we should also check that if the prices array is empty or not to get a runtime error in this code. Next, we start iterating through the array, starting from the second day. If the current profit is less than 0, we update the purchase value with the current price since it's a better option. So let's calculate the current profit. Now update the buy value. If the profit is not negative, we check if it exceeds our current maximum profit. If it does, we update the maximum variable accordingly since we have found a better profit we can achieve. Else, we can do this comparison like this. Finally, we return the maximum value. Now, let's discuss the time and space complexity of this solution. We iterate through the prices array only once, and the time complexity is going to be O(n), where n is the length of the prices array. And the space complexity is constant because we don't use any additional data structures or array. We only utilize two additional variables to store our data. Now we can check the performance of the solution on Leetcode. I hope this explanation has been helpful to you. Thank you for watching.